Okay, this is question 2 of homework M3, and in this question we've got a triangle, KLM. We're given two sides in terms of vectors, so k to L is 3i plus 0j minus 6k, L to M is 2i plus 5j plus 4k. And what we've got to do is show that the angle KLM is 66.4 degrees to 1 decimal place. So this is basically a question where we've got two sides. We can use these two vectors to find the third side, and then we can then demonstrate that this angle is 66.4 by using the cosine rule. So really it's a relatively simple vector question, and then takes us back into GCSE territory with the cosine rule. Finally, we've got to find the remaining two angles. Okay, so what we've basically got is a triangle, KLM. We've got KL, this vector, LM, this vector, and then we can find this vector KM just by simply adding these two vectors together. So the vector K to M is the same as going from K to L plus L to M. So we go from K to L, then we go from L to M. Add these two vectors together gives us KM. So we'll just add that in column form, just slightly easier to see what's happening. And so we get 5, 5, and minus 2. So this is the angle KLM that we need to show is 66.4 degrees. And so we've got now basically the three vectors. Let's write this one down here. 5i plus 5j minus 2k. And so what we'll do is we'll find the modulus of each one of these vectors and then apply the cosine rule. So the modulus of vector KL is simply equal to 3 squared plus 0 squared plus 6 squared, and then the square root of all of that. So that gets me 9 plus 36, which is the square root of 45. For vector LM, it's now going to be the square root of 2 squared plus 5 squared plus 4 squared, which is 4 plus 25 plus 16, which again gets me the square root of 45. For the vector Km, its modulus is going to be 5 squared plus 5 squared plus 2 squared, which is the square root of 54. So all we've got to do now is apply the cosine rule to our triangle up here, and we'll just relabel the sides. If this is big M, this is little m. If this is big L, this is little l. If this is big K, this is little k. And it's basically angle big L that we're trying to find. So we can say that little l squared is equal to little m squared plus little k squared minus 2mk cosine of big L. And this is the thing that we're trying to find. So we've got L squared, which is the square root of 54. So we're going to square the square root of 54 to get 54. We've got m squared, or we need m squared. We've got m, which is the square root of 45. So we square that to get 45. Likewise with k, we square this to get 45 minus 2 times the square root of 45 times the square root of 45 times the cosine of L. So simply rearrange now. We've got 54 equals 90 minus 2 times 45. That's 2 times 90. Root 45 times root 45 is just 45 times cosine of L. We'll take this onto the left hand side and the 54 onto the right hand side. So we now get the cosine of L is equal to 90 minus 54, and then we divide through by this 90 to get 90 down there. Substitute the values into the calculator, and we get cosine of L being 90 minus 54 divided by 54. So cosine of L is 0.66. Sorry, let me do that again. So cosine of L is 90 minus 54 divided by 90, 2/5. Inverse cos of the answer gives me 66.4 degrees. Okay, which is exactly what we're looking for. Now the question then asks us to find the other two angles, this angle and this angle. Now this side is root 45, this side is root 45. These two angles must both be the same. So in part B, we know that the triangle is isosceles. So to get these two angles here, we call these two angles, say, angle X and angle X. So we can basically say that 2 times angle X plus 66.4 is 180 degrees, and then we just solve for X. X is 180 minus 66.4 divided by 2, and that gives us 56.8 degrees.